Good afternoon, everybody. Shall everybody take their seats, please? There is plenty of room for everybody, so take advantage of all the remaining empty seats. And if you need a translation into Spanish, outside they are providing, outside that in Spanish. Hay traducción del inglés al español fuera. O sea que quien quiera necesite auriculares que los pida fuera, por favor. Sorry. And be quiet, please. I will ask everybody to be quiet. So it's my pleasure. My name is Álvaro Azcárraga. I'm the former president of this federation, and I was asked to kindly asked by the federation to be your host tonight. In fact, it's my pleasure and honor to be the host of such a very important meeting, although the moderator role is going to be played later on by the former head of the Astronaut Corps of the ESA, Mr Andres Ripoll. My understanding of the events is that today we are going to start with a small movie, and then I will pass the floor to Mr Ripoll, that will make an introduction of the European astronauts present here, and then each one they will talk. Later on, I hope that the Chinese taikonaut, an astronaut from China, will join us. And at the end, the idea is to have a real open session in which questions they are going to be asked by the floor, and everybody will freely answer those questions and maybe have a more informal discussion on the floor. So that's all as far as I'm concerned. Please, we may start having the... Thank you.
Good evening, ladies and gentlemen. In this beautiful environment of Valencia, let me first welcome all of you to this plenary event entitled Living Your Dreams. In my view, this is a very proper title for a session of the Congress organized by the International Astronautical Federation, since historically, the wishes of men and women to travel to space were long-awaited dreams for humankind. I'm sure you all remember the first flight to space by Yuri Gagarin 45 years ago, where he opened a new era, the spaceman exploration. Since then, less than 500 people had the opportunity and the glory to be members of a very exclusive club, the astronauts and cosmonauts. This evening, you have the opportunity to listen 6 of the most experienced astronauts. They are now sitting near me around one that will come later. If you had a chance to read my curriculum, you may remember, or you may understand, why I'm so proud with the European Astronaut Centre, the European astronauts, and also the manned exploration missions. They feel a large part of my experience, and also they feel a large part of my heart. The plenary event intends to provide astronauts perspective on current and future space activities. Considering the fact that all of us at this table are Europeans and members of the European Space Agency, the plenary event aims globally to do the following: project the sentiment that the International Space Station is an ongoing project central to European interest. This is the present. Promote Europe's strategic vision beyond the goals of the International Space Station. That is the future. Pass the message that the exploration of the Moon and Mars is also pursued by the European Space Agency. Those are the wishes and the facts of ESA. In order to accomplish the above objective, the panelists of this plenary event have prepared some presentations based on their present missions and responsibilities, which altogether pretend to cover most of the aspects of the European Astronaut Centre, the European Astronaut activity, present and future. To summarize a long and very active professional life is normally a difficult task, but in this case, of the 5 astronauts surrounding me, it sounds an almost insurmountable enterprise. Indeed, I feel not so happy with the short curricula I will have to summarize for each of them. They deserve much more, as it is proved by the amount of special honors that all of them have received. Before continuing, I want to mention that according to the program, we were expecting to have also an European astronaut, Roberto Vittori, but he couldn't come, and instead we have another astronaut that used to be the boss or the head of the European Astronaut Centre, Dr. Ernst Messerschmitt. Let's first begin with Michel Togini, the boss. Born in France, he gained many qualifications and honors as a fighter pilot, test pilot, and professional pilot. He is also an engineer and very well known as astronaut with more than 20 years of experience. Qualified as astronaut in the Star City in 1986 and NASA Johnson Space Center, Houston in 1995. He has accumulated around 21 days in space in 2 missions. The Soviet-French Antares in 92, in the Mir Station, and the STS-93, where, as member of the shuttle crew, they deployed the Chandra X-ray Observatory in 1999. Since January 2005, he is the head of EAC. Of course, in this case, you can guess that no one is more qualified than him to talk about the European Astronaut Centre. Michel had the words.
Ladies and gentlemen, good afternoon, and thank you for inviting all the astronauts to speak to this plenum. I would like to start with the name of this presentation, which is Living Your Dreams. But in fact, that means the dream is alive. What is the dream alive? It is the reality of today, which is a European citizen, and Europe is ready to go to space and to participate to the biggest adventure, which is a space station. So the European Astronaut Centre has been created a little bit more than 15 years ago, in 1990, and you can see inside some picture of this center, which is made in Cologne, Germany. A little bit after, in 1998, we have unified all the astronaut corps from the national countries to one corps, which is also has a home base in Cologne at the EAC. And we have also integrated all the specialists for training or for medical purposes from the space agency from Germany, France, Italy, in order to have a team of people having the best competency to support the astronaut. So EAC today is about 100 people, so the number has grown a little bit through the years, and you can see a picture made a few years ago. We deal at EAC with training of astronauts, medical operation for astronauts, astronaut support and management, and also crew operation tasks like Capcom or like Eurocom. The team of EAC is kind of unique because we have people coming from 12 different countries, and they are all communicating together, which gives a flavor which is really in good order to prepare the work on the space station, which is already made with 5 different countries. So this is a summary of the organigram of the EAC with the astronaut division, the training division, medical support, and we have a new division called Human Exploration Promotion. Why we have this division? Because the ISS is really the preparation of the future, which is exploration, and we give by this division an alternate access to space on a commercial way for the science which is not peer review, and also for education, which is a student that would like to fly an experiment can have access to space. This is in line with the text of the space station, And also, this experiment could be, in the future, a very best experiment, which would be peer review. We also work on the support for industrial development through collateral duties that we do with astronauts or with some of our engineers. We have been involved, obviously, with the preparation of Columbus ATV and projects which are side projects like the CRV or the X-38, which are the vehicle that were supposed to be in cooperation with NASA and ESA. We have also a technical assignment on the main payload of Columbus and reviews on the other smaller payload and participation on the reviews with astronauts from different countries like NASA or Russia. We do ISS training. The main goal, the main part of EAC is to provide the ISS training for all members of the space station, knowing that each partner has to provide the basic training on his own country, but after that the training on the part made by Europe, for instance Columbus and ATV, the training for that is made at EAC. And NASA is coordinating the whole training template through the 5 partners. The training flow is kind of complex for European astronaut, and the next astronaut to be selected will have to have this picture in their head, which is after the selection you have 1 year of basic training that you make at EAC in Cologne, and after that you go for about 1 year advanced training in the 5 centers corresponding to the space station that you see on yellow on the left side, and then you are assigned to a flight. This is a crew assignment. You start a flow of backup training, which is a minimum of 1 year, and after you have the flight training as a prime crew, which is also 1 year, 1 year and a half. So if you see from the selection to the flight, it's about 4 to 5 years. And not only it's 4 or 5 years in one center, but it's 4 or 5 years with your suitcase traveling between 5 centers, and knowing that in the last 6 months the most important training has to be performed. This is really, really difficult, and the next astronaut will have to be smart but very resistant in terms of jet lag accumulation and so on. This is what we do at EAC, and you see the facilities. On the left you see the biolab facilities with an astronaut, Umberto Guidoni, working on it. You see the Columbus and ATV trainer, and we have also a swimming pool called the Neutral Buoyancy Facility, where we do some pre-familiarization training for people doing spacewalk training with NASA or with Russia. We have also the control of the medical operation for ISS made at EAC. So we have a control room where we talk to the astronaut regularly. We have a private medical conference with him, and we assess, especially very important for long duration flight, we assess the psychological behavior of the astronaut for long duration flight, and we take the good measure if needed on time. The perspective is to have also more involved of this medical board and medical people during the flight in the future. Now what we do is link to the space station. I will give you a few words for the ones that don't know yet what is a space station. So it will be 3 times bigger and larger than any other space station built. This is in reference to the previous space station, which was Mir, and about 108 meters long and 1,200 cubic meters of volume. And the inclination is the same as Mir, which is 51.6 degrees, so you can cover most of the habited part of the Earth, and altitude 400 kilometers, which is oscillating between 350 and 400. And the speed is a normal speed for a satellite at this altitude. So, to come back to the ISS, it's a unique program because it's a cooperative agreement between 5 different countries. And when I talk Europe, it's not a country yet, but it's ESA making a partner, and it's the only partner which is constituted by different partners. And the main point is it is a barter type of work. We have no exchange of funds. We just, for instance, we launch Columbus, we barter Columbus with the launch of ATV. So there is a return on our industry and a return on the European citizen. We joined the program in 1996, and Russia also joined the program in 1993. So the main part of Europe in this space station are the most important are the ATV, going to be launched next year after May, June of next year, launched from Kourou with the rocket Ariane 5, and docked to the space station. The first flight will be a test flight. It's a unique vehicle because it's a fully automated vehicle, and no other vehicle of this type exists in the world today. The second big part is Columbus. It's one of the most complex laboratories in space, going to be launched next year in October. The Note 2 is also made in Europe, partially made in Europe, launched in August next year. We have other parts that have been developed in Europe, DMS data management system on the Russian system to communicate between the Russian and the American system. We have some payloads that you can see. ERA is a robotic arm going to be launched on a Russian module called MLM about 2008. And we have also other systems like the Cryo system, Melfi, and the Cupola to be launched in the future. So Columbus, as I said, is a very complex laboratory. The ATV and the astronaut corps made ESA, give to ESA a full access to the space station, which is an autonomous access to the space station, but it is a strong cooperation between the partner and ESA. And now you will see a small video of what has been done in terms of space station.
Thank you.
It's not finished yet.
Adversaries and former enemies can come together.
I have long believed that a society that stops exploring is a society that stops progressing.
This program is the bridge to the future for human spaceflight.
What happened in this last year is truly phenomenal. Space station today is the largest and most capable space station ever flown.
Liftoff of the Soyuz rocket, beginning the first expedition to the International Space Station and setting the stage for permanent human presence in space. Permanent human presence in space. Human presence in space. Presence in space. In space. In space.
I would like to conclude the presentation on the picture of the European Astronaut Corps. It's also a unique corps. So you have seen on my presentation, I have used the word unique many times, but it's really a unique corps because it's the only corps in the world composed by 8 different countries of Europe, but all serving the flag of ESA when they go to space. And most of them speak Russian and American and English, I mean, in order to fulfill the flight we have with Russian or American. Thank you very much.
Michel. Thank you, Michel, for this very interesting presentation. And I would like to ask you a question now, because I'm sure it's in the heads of many people. Looking back the early beginning of the European Astronaut Centre, the project, the future and the present status of the Centre. Can we, as Europeans, be proud of these accomplishments? And second, is the International Space Station ever going to be finished? I believe these are two questions that everybody has in mind. Can you say something about it?
So I really would like to share with you that for Europe and for European people, we can be proud of what we have done in terms of participation on the space station. Obviously, for budgeting reasons, we couldn't have the full autonomous access to space. So the choice was to have a strong partnership in the space station, to join the space station, and we joined the space station with two programs that are complementary. One is science with Columbus, with extremely complex payload and science, and one with ATV launched by our own launcher, Ariane 5, and which has also a very specific quality and which is also different from what has been done in the future. It was in the past. It was really important for Europe not to duplicate that was done in the past. So we have an ATV which will be roughly 3 times bigger than the Progress, and that will really help the space station in the future. And for the second question, which is, do we believe the space station will be finished one day, finalized one day? Well, we work in terms of trust relationship, and the people that you see on the panel here trust the Russian and the American, because we all flew in space with Russian and American, and when you fly with them in space, you have to trust the technician and engineer. And Mr. Griffin said that they will fulfill the 16 or 17 flights necessary in order to go to the end of the assembly of the space station. He demonstrated that the 2 first flights were successful, and the press reported they were fully successful. We had many cameras in order to show that the foam was not lost on critical time and critical point, and I believe the space station will be finished before 2000.
Thank you again. Next speaker is going to talk about... Sorry, it will take some time to learn this. Okay, next speaker is going to talk about the European astronaut in space. Gerhard Theile was born in Germany. He received his doctorate degree in physics at the Institute for Environmental Physics of Heidelberg University in 1985. His experience in manned space flights started in 1988. He was backup payload specialist in the German D2, a Spacelab mission. This was 92. His spaceflight experience is about 11 days as a mission specialist in the STS-99. This was a mission dedicated for the first time to digital 3-dimensional mapping by radar of the Earth's surfaces. At present, Dr. Theile is the head of the astronaut division in EAC. Gerhard, you have the word.
Thank you, Mr. Ripoll, for the kind words of introduction. Ladies and gentlemen, my talk is titled European Astronauts in Space, but before I start into my presentation, please allow me a few introductory remarks. The first one is I'm very glad to see so many young faces here in the audience, and as a matter of fact, we have some very young faces in the audience as well. And the very young faces, of course, are our children. I cannot imagine a better symbol of our future than our children that we also see here amongst us. And what we are reporting here today to you is, as a matter of fact, preparing the future today. And so keep this in mind. We are preparing the future of our children, and this is what we are presenting to you today here. To be specific about my part, to put that into perspective of what you will hear, the future has, of course, a narrow perspective, and this is what is happening in the next 1 year. This is my part, and it will have a broader perspective and a wider one, and I will leave that to my colleagues who will come. So having said all that, let me start about the European astronauts in space. And the first very remarkable thing that you can see, and you probably guessed it after the presentation of Mr. Togini, is that we are not only a very diverse group, but also a very spread out group. We have, of course, one person right now, and I should say we are spread out literally over the globe, and this is especially true for one of them, namely Thomas Reiter, who you see represented with the blue box in the middle, because right now he is on board the ISS. And by the time this session will be over, he will have circulated our planet already once. So he certainly is the highest flying European astronaut right now, but we have the ones in the red boxes in preparation, and at the bottom you see 3 names. They are preparing for missions to the ISS. And you see on the left side over the soil of the United States 3 other names, and I will come to that in detail later, who are preparing for shuttle missions to help build the ISS. On top of these 7, we have 3 more in Europe. Claude Nicollier, who is with us today on the panel and will talk to us later on. And he's the only one at the European Astronaut Centre right now. Jean-François Clairvoy of French nationality and Roberto Vittori are detached to their home countries. I would like you to remind from my presentation only 2 slides, and this is one of them. What is so specific about this flight? The ISS was launched back in 1998. It has been inhabited now since 6 years, and as you can see, it has taken more than 120 people to build the ISS and to visit the ISS. And Europe was a significant part of it, with 8 astronauts from 6 nationalities visiting the ISS. It started in 2001 with Umberto Guidoni, and it is hopefully not finished with Thomas Reiter, who is flying right now. But the message here is Europe has already been participating in the build-up of the ISS with 8 flights in 5 years. 8 flights in 5 years, which is not little, but wait what is coming. Now, what has happened until now? Yesterday, this is the time when Thomas launched in July. This was the configuration of the ISS. In September, we had the successful completion of the last shuttle mission, and you can see that there were some significant changes, especially visible in the solar panel arrays, which brought more power to the station. We will see another significant change in December this year, and we should be, and we are very proud that we are part of it, because Christoph Fuglsang from Sweden will participate to that mission. Then the station will get a more regular shape again in February 07, one of the few missions in the coming year without European participation. It will continue successively. We will build a bigger station, as Michel has already pointed out, and Paolo Nespoli in August 2007 will be part of the mission where we put on Node 2. Now, the nodes are key elements, because the nodes you can basically see as the ones that receive the key modules like Columbus, which is so essential for Europe, and the Columbus module will be attached by Hans Schlegel and Leopold Eharts in September 2007. Let me address the mission that is going on right now, which is the mission called Astrolab, flown by Thomas Reiter. It is a very special mission for a variety of reasons, because Thomas was a member of an expedition which we refer to as Expedition 14, which has returned to Earth on the Soyuz spacecraft just a few weeks ago. Pavel Vinogradov was the Russian commander, and Jeff Williams was an American flight engineer. And since mid-September, they have been replaced by Michael Lopez Alegria and Mikhail Turin. And they are preparing the next missions for us right now as we speak. And with this, I would like to show you a greeting address from Thomas, and I hope we can hear his voice in a second.
But for a few minutes we would like to share with you the atmosphere up here in space, which has been a quite busy place in the last few weeks. As you know, the Space Shuttle Atlantis delivered a new thrust segment, a huge solar array. This way we have almost doubled the capability of the station for electrical power generation, and this paves the way for the reception of the European module Columbus and the Japanese laboratory, which will come up as from next year. A few days later, we welcomed our new crew, which has brought up, also a tourist, and she has already left. As I mentioned before, it is our commander, Mike Lopez Alegria, born in Spain, and from NASA, and Misha Turin from the Russian Space Agency. With a crew of 3, the ISS is indeed now a kind of shining example of international cooperation. For Europe, we are on the brink of a new era in spaceflight. Within the next year, we will see our first ISS supply craft, the Automated Transfer Vehicle ATV, travel to the space station. There will be 3 more flights of my European astronaut colleagues, and finally we expect the arrival of Europe's own space station laboratory, Columbus. Apart from the science made here in space, our work reaches out into the far future. We gain experience building the space station and research into the effect of long-duration spaceflight. All this contributes to the next steps in space, humanity's plans for the future exploration of our solar system.
Buenos días, es un placer poder saludaros desde aquí con mis tripulantes. Los que piensan en nuestro futuro en el espacio a largo plazo, tanto como los que están haciendo actualmente, han decidido reunirse esta semana en España, precisamente en Valencia, para plantear a dónde vamos y cómo llegar. Durante esta semana también se contemplará cómo se puede utilizar el espacio para solucionar problemas terrestres. Un ejemplo es el uso de la tecnología espacial para ayudarnos con la cuestión que cada día es más de interés global: cómo podemos usar de manera más eficaz uno de nuestros recursos más importantes, el agua. Les invito a todos que estén en Valencia o que puedan acudir a la ciudad de las artes y las ciencias esta semana de aprovechar de este congreso, de asistir a sus eventos públicos y de averiguar lo que el espacio nos puede traer. Muchas gracias.
Дорогие друзья, дорогие коллеги, экипаж 14-й экспедиции от всей души приветствует ваш конгресс и желает вам всяческих, всевозможных, мыслимых и немыслимых успехов.
Thank you very much, and many greetings from the International Space Station. All the best to you for your congress. Bye.
Well, I think it is fair to say, if I respond on behalf of you, thank you very much, Thomas, Mike, and Michael, for this kind message. And it just seems to me that we can't build this station without the people from Spain. So, with that, I now come to the second slide that I want you to remember, not the details, but what you see here are 4 European astronauts, and if you recall the first one, it showed 8 astronauts who have flown to the ISS over 5 years. Now we have 4 astronauts flying to the ISS within just 1 year. So this shows you that the pace in Europe really has picked up, and that we are about to really build this station and bring it to a completion. And this is what I want you to take away from that. And I just mentioned briefly what these 4 missions are. As a matter of fact, I have explained it to you, but I want to introduce the European astronauts a little bit closer. Christoph Vogelsang has joined ESA already a long time ago. He has waited a long time. He will fly in December, and I am especially glad and happy that he gets a very challenging flight, including 2 EVAs, extravehicular activities, and about this special activity we'll hear more from Claude later on. Then we have Paolo. I have mentioned that he will bring up the Node 2, a key flight before we can attach Columbus. All these activities include heavy extravehicular activities. Paolo has the critical task to stay inside, not enjoy the view from outside, but he will stay inside as the conductor of these 3 spacewalks, because we have what we call an IV, which is an intravehicular expert who orchestrates all the activities that are going outside. So he will tell the people outside what to do next, and he will do that for all 3 EVAs. It's a huge responsibility on his shoulders. And this will be then followed by the flight that ESA is eagerly waiting for, which is Columbus. It is currently planned to launch, I apologize that the date is not quite correct, in October 2007. And Hans Schlegel will perform 3 EVAs connected to the attachment of Columbus. And inside stays Leopold Ehards, and he will not stay only for the 11 days, but he will continue with the next increment, which will keep him in orbit for roughly 2 to 3 months. So it will be a flight similar to the one that we are experiencing right now. This concludes my presentation to you. Again, Europe is in the process of contributing significantly to the build-up of the station in the coming year. We need your sympathy and we need your crossed fingers so that everything works out. As I said again, as I said at the beginning, we are preparing this for the future, and that means also for our children who are sitting here with us. Thank you.
Thank you, Gerhard. Was also quite interesting, your presentation. But again, just thinking on the general public, I might like to ask you one question, and is considering the profile of the future exploration mission as to the Moon and Mars and so, all of long duration, isolation, extensive EVAs, etc. Are the space agencies already thinking on new criteria for selection as medical, psychological, and professional?
This is a very good question. Thanks, Andres. Of course, I was limited to just what is happening in the next year, but we are indeed thinking already beyond that time frame, as the next presentations will show. And as a matter of fact, we are preparing the next round of astronaut selection. And we have in mind the profile of the people we need there, and currently these discussions are exactly ongoing. What kind of astronauts do we need? What profile do they need to have? But it is fair to say that the past selections that we have made has shown that we have selected very good astronauts, and I would have all the confidence that if we would have the same quality in the future selections with the same quality of people, that we will master the challenges that are ahead of us.
Thank you, Gerhard, again. And next speaker is Professor Ernst Messerschmitt, former boss of EAC from 2000 to 2004. He was born in Germany and received his doctorate degree in physics at the University of Freiburg-Breisgau. Selected as science astronaut by DLR in '78, he was assigned to the German Space Lab mission D1, where he flew as member of the crew of the last successful flight of the shuttle flight Challenger. This was in '85. In 1986, Dr. Messerschmitt started to be professor and director of the Space System Institute of the University of Stuttgart, where he developed a very intensive and productive academic work as you can easily recognize if you read his curriculum, with the high ranking positions he held and his 140 publications, 10 patents and several books he wrote. In fact, his talk is going to be very interesting, related with his professorship and his focus on education and exploration. You had the word.
Thank you, Andres, for your kind words. In fact, working 25 years or more for space meant exploration and education. Exploration because before becoming astronaut, you have to explore yourself, how far you want to go, what you dare to do, and are you ambitious enough to join a spaceflight program. I did, and I was one of the first flying Space Lab. When we look in a few moments in the future, we have to think also of the past. Space Lab is probably the most successful program, science program flown in space. It is one of the most heavy payloads brought by the space shuttle to orbit, but also it is the most frequently flown. It has been flying 16 times, this space laboratory, as you see it here on the picture, and at several other occasions with other type of hardwares. And this is the stepping stone to join the ISS, the International Space Station program, as a partner with a strong focus on science. In fact, if we look at the objectives of European utilization of the space station, of course, research comes first. Life sciences, physical sciences, space sciences, where we try to solve questions that are important for us: how to improve health, how to understand better processes, combustion processes, how we can produce better materials, and so on. But also we use ISS as a test bed for future technologies. When we go further beyond ISS orbit, we need new, better life support systems. We need more autonomy, more reliability, and a strong emphasis on safety. Also, we would like to generate business. We can use for technology development and also for science data needed by industry, the International Space Station. So there will also be some growing market on business. And the last but not the least, that is education. I'm proud to say that ESA at least spends 1% of the utilization program for education of students, of young professionals, using that to attract students for engineering sciences, natural sciences, and so on. Now, if we look what is in front of us, that is definitely ISS. Whenever we talk about going to the moon, to Mars, of course, first we have to prove that in low Earth orbit we do our job. And that takes another 10, 15, 20 years. And probably the space station will be as long as reasonable in terms of maintenance, etc. Also, we need the space station, and we need some more time to ask ourselves why we go further. And here at this conference, the International Academy of Astronautics has key experts in asking those questions, formulating the questions where we don't have the answer yet. And I collected some of the questions, fundamental questions that lead to exploration objectives. For example, where do we come from? We can go to the next layer of questions, more specific, determine how the universe of stars and planets began and evolved. And we have to determine what our origin was and how we further evolve with our biosphere. And another fundamental question is, what will happen to us in the future? And to go on, are we alone in the universe? And if we try to ask those questions and find the answer, we come automatically to our objectives, why we cannot stay only with the ISS. We need ISS as a stepping stone, maybe even as a waypoint station where we assemble large structures which we take on our further voyages. And those objectives then lead to mainly 4 destinations or group of destinations then that we can reach in the next 50 years. Next year we have 50 years of space, of operational space, and we have to make plans also for the next decades. And those destinations are not only the Moon, and not only the Mars, there are other locations which are of interest. And I would like to quote one of those, or a group of destinations. These are the libration points close to Earth, close to the Moon. That is the locations where the attraction of the bodies of the Sun, of the Moon, of Earth cancel. And those are very interesting locations because we, the world community in space science, plans to have at least 10, 15 telescopes by the year 2020 to look from there out to the universe. And this is, for example, the imagination of those who make the plans for those kind of support. So when we talk of exploration, that is not only science, that is also as a part of our cultural imperative, that is using space, serving space or space sciences, for example, as we did with the Hubble telescope, maintenance and repair of big investments of space. And I, as a professor at the university, just to demonstrate what can be done by students, is to transform mission statements of future missions based on the heritage of the space station, where we use also further developments of the Ariane 5, of the autonomous transfer vehicle, etc. So we have those infrastructure, we have the inventory to go further as a logical next step into space. But before we do that, we have to use the International Space Station, and the more we do that, the more we learn how to be more efficient, also going to low Earth orbit and further away, and then to the Moon, traveling to the Moon, doing some science work or exploration there, maybe exploitation one day, like 40 years ago in the Apollo times. That takes about 1,000 hours. Flying to Mars, that is 1,000 days, and that is a whole different story. And and that's why we use the International Space Station and waypoints in between to gain experience. But only we are successful if we communicate that to the youngsters or to the students, to attract the students to follow us as scientists and engineers. Thank you.
Thank you, Ernst. It was very, very interesting, your talk. And in fact, this brings to me a question again, general question. With the amount of knowledge acquired by our society during the last 50 years of space research and exploration, and seeing that it's so huge and so complex, am I right in saying that one of the great difficulties in education will be to find ways and methods to synthesize all this knowledge? How can we train a new astronaut in the future with this knowledge?
Thank you for this question. The first part is related to everyone. That has to be taught, that has to be taken into the information process. So we have to communicate our objectives and our findings we have so far in the from the past 50 years. Only when we can convey what we have achieved and provide the insight, what it means, this kind of science on board of ISS, we address the broad public and we get the funds for the future. And even more complicated and difficult is, of course, to train the astronauts of the future with all that information needed. And we have to use the most modern tools knowledge management, and also of getting international, not only international and multilingual, but also get adapted in terms of our multicultural background. And that is the great challenge of the future. In a multicultural environment, interdisciplinary, when we talk of science, international, of course, in an extraterrestrial space, that is the true challenge, just to name the 4 buzzwords. And, well, we tried, and let's see, we shall succeed. Thank you.
Thank you. Well, we have arrived at the next speaker is Pedro Duque, very well known here in Spain since he's the first Spanish astronaut. He was born in Madrid, where he obtained the degree of aeronautical engineering from the Polytechnic University of Madrid. This was in '86. He worked in the European Space Operations Centre, ESOC, and in 1992 he was selected to join the European Astronaut Centre in Cologne. As European astronaut, Pedro has accumulated 19 days in space in 2 missions. The STS-95 in the Shuttle Discovery, this one in 1998, was his first space flight. He was also responsible there for the 5 ESA scientific facilities on board. His second mission of about 10 days was to the International Space Station, flying on the Soyuz as flight engineer. And, in fact, he's going to talk about this second mission. He's going to talk about the Cervantes mission. Pedro, you have the word.
Thank you. Thank you, Andres, and I address the congressmen of the International Astronautic Congress. Congratulate you for the great success of the Valencia Congress this year. Bueno, para los pueblos de Valencia voy a hablar en inglés, creo que lo están traduciendo, así que no creo que tengamos problema ninguno. My intention is to speak to give an impression of the feeling of getting to space. How does it feel? What does one do to get to space? And what are the different stages that one goes through? 2 different ways exist today of going to space. One is the space shuttle of NASA, and another is a rocket, let's say a traditional rocket that goes in line and the astronauts are sitting on top of it. In fact, there are 2 models of that rocket nowadays in operation. One is from Russia and one is from China. The rocket or the shuttle, they prepare for many, many months, but still the crew has been preparing for quite a much longer time in advance. The astronauts feel the approach to the rocket very slowly. You have to train for years in the knowledge of how the rocket actually works and how the experiments are going to be conducted. And at the time of these 2 pictures, the astronauts are already in their very last phases of preparation. The rockets, they move very slowly from the big hall where they have been put together to the place outside of everything in which they are going to be launched. On the left we have the space shuttle that is moved in vertical position, and this is a very large structure that moves on sort of caterpillars from as we say, the assembly building to the launch pad. Of course, the astronauts are not on the rocket yet. And on the right side we see the other system, that is the Soyuz system. I haven't seen pictures of the Chinese system, but I have the impression that it will be not very different from a technical point of view. This goes on rails and is moved a much longer distance, but that's only anecdotal, from the assembly building to the launch pad. As we say, the astronauts are not yet there, and well, it is of course significant that one moves horizontally and the other significantly. For the engineers, that's very important. For the general public, that's probably also anecdotal. And as I say, the astronauts at the time that this happens are already in the last phases of preparation. They are really looking forward to approach the rocket. In the case of the space shuttle, sometimes it goes to the launch pad many weeks in advance. The Soyuz rocket only goes there 2 days in advance, or actually 1 day in advance if you count the night. And this is already at the moment that the astronauts are almost putting on their suits. The rockets start to be fueled. All the fuel starts to drop into the reservoirs, and at that time is when the astronauts put on their space suit. Launch is, of course, the most important event of going to space, and the one that gives one the strongest feeling. The launches are somewhat similar in the sense that people are sitting on the top of the rocket, but of course with the back is horizontal and their feet are high. This is the way you sit on a rocket when you're launching, both in the shuttle and on the Soyuz. The shuttle starts by a 1 minute move that buffets a lot, that vibrates a lot, and gives you an impression of course, enormous power, which it has. It weighs 2,000 tons on the ground and weighs only 100, maybe 110, 115 tons when it gets to space. So all the rest is mostly the amount of fuel and matter that it burns. The first minute is a big buffet, and then after the second minute, the side rockets pull out from the shuttle, and from then on, the ride is very smooth. You just feel the shuttle pushing you further and further and further into space, and giving you more and more velocity until, of course, you reach enough velocity so that you're in orbit. Soyuz rocket is different in several ways. It starts smoother than the shuttle, but then of course it is liquid fuel, so that is natural that it happens like that. And it has a little bit of a rocking motion. Of course it's just like a stick, so it is a little bit less stable than the shuttle can be. And it has stages, so it is not like the shuttle. When the shuttle drops the two side rockets, it keeps pushing upwards. When the Soyuz drops the first stage, it drops a little bit, and then the rest of the rocket keeps pushing upwards on you, but you have the sensation that you're falling actually in the middle of it. And then the same happens more or less with the third stage. As an anecdote, you see that there's a hole in here. You can see through the rocket. This is because the third stage starts, the engine starts before the separation has occurred, so before the second stage is over. So then all the fire comes out of the sides, and that's the way they make sure that the third stage lights very reliably. And this time, of course, the astronauts are already on top of the rockets, and they're already feeling all that buffeting. As an anecdote also, you see that the launch of at launch, the Soyuz has an extra tower on top that is not an antenna, and it's not a lightning rod. It is there in order to escape the rocket in case there's an emergency. In the case of the shuttle would have to detach from the rest and fly back. We all hope that this is not needed in any case. The feeling of going to the space station is of course very different in a shuttle or in a Soyuz. the shuttle is much bigger inside, so therefore it has very, very large windows through which you can see the Earth or the space station as you approach. This, of course, gives the shuttle a much comfortable feeling when you're going to the space station. In the case of the Soyuz, of course, as you see here, in the beginning you're sitting in a capsule that is just barely big enough for holding the people, and then afterwards you can take off the spacesuit and be more normally suited. And there's another compartment up on top of the capsule that can be used. It is slightly larger than the capsule, but still it's a ride that is not very comfortable going to the space station. The windows are on the side, so you don't see the space station as it approaches. You only see it on the television screen. So that is more or less the impression of how you get to space. You normally fly for 48 hours in the capsule or in the shuttle, making very small maneuvers in order to match the velocities of the two things, of the space station on one side and the shuttle on the other side. This is, of course, essential in order to be able to dock. And this is the space station inside. Once you're there, you don't have a spacesuit, obviously. This is the end of the space station. There's, of course, a door in order to dock the shuttle and be able to enter the space station. This is what we did with the Soyuz when we came up there. But all the crews, of course, have to after making the after approaching and docking, then they have to open a door on each side. This is a glove box, a place where you can handle experiments that may be a little bit harmful or may contain chemicals or biological samples, and in that way, if you put them inside there, the samples or the chemicals cannot escape, and you can work safely with them. Of course, you can imagine everything floats, so bad chemicals or bacteria, they all float too, so we have to be very careful with the experiments. On the computer we see the plan of every day. We write emails to the ground control, to whoever, the family or the friends. We read our procedures. Basically all the time we're looking at the computer for one thing or the other. That's a way to attach yourself so that you can work on the space station using your knees. And here's the best place in the whole space station. That is the window that looks down. Unfortunately, we cannot be all the time down there, but as you see, there's fires, probably, and this blue color is the normal color that you see when it's green. When it's green down there, so it's a jungle, and but it is very humid. So this is more or less the color of the Amazon or the Congo. We do experiments all the time, aside from the time that we are taking to show you what we do. The rest of the time we're doing experiments, and this was one of the experiments that we're showing. I have no idea how to play the piano, but one of the crew members did, so there's a piano always ready. One has to show happiness somehow in videos. It brings the attention of everybody. Do not kick the computer. That is the most important thing you have to remember is never kick the computers. And there's another part of the space station that is extremely singular, and that is the place where the spacewalks takes place from. Now we close the passport control between the American and the Russian side as a joke, and we show that there are modules. Each module is a cylinder. They are mostly attached one on the end of each other, but there are also modules that are attached towards the right side. And here is already the central part of the space station, the part that is used for control. Here you have the Russian and the American side to control the procedures, as we said, what we have to do, when do we have to do it. This is all here. And of course there's normal life of people up in the space station. We're not, we are still human, so we have to still speak and go to the bathroom and sleep and go to the bathroom and eat and everything. So there are all sorts of necessary facilities on the space station. This is the bathroom. Of course, it works with air currents that replace the gravity that is normally used in Earth bathrooms to get rid of all you don't want to have anymore. And that's it. This is the end. That's the way you move around the space station. Well, thanks very much for your attention.
Pedro, thank you very much for this interesting and relaxing trip through the station. Let me ask you one question, since you had been in the space station doing some experiments. You and several other European astronauts have already had the chance to use the International Space Station as a space laboratory for a set of experiments, Andromeda, Marco Polo, DZ, Delta, Eneide, Cervantes, etc. Have they served the projected purpose? Do you think that now the European scientists and potential users of International Space Station, unique conditions, can make use of them efficiently?
Yes, all these experiments that we did during all these years have not only achieved results regarding science. By the way, we have had a congress in Toledo in June this year in which all of them came together and produced a tremendous amount of scientific output. But also many people on the ground have learned how to do it, how to exploit the space station, because it is not so immediate. There are many different steps that you have to go through from the concept of the experiment to the realization of the experiment. And we have learned a lot. We are way ahead of many people. And by the way, the largest part of the science that has been done on the space station till now is European. So we can be proud of that part too.
Thank you very much. Next speaker, that is the last one of this session, and by no means is the last but not least, is Claude Nicollier. He's a senior in the European Astronaut Corps and was one of the few members of my team when we started in 1988 to build up the European Astronaut Centre. I'm sure he remembers this very well this time. Born in Switzerland, he graduated in physics from the universities of Lausanne and Geneva. He graduated also as Swiss Air Force pilot, airline pilot, and test pilot. Nicollier is a veteran of 4 space flights, has logged more than 1,000 hours in space, with 8 hours, more than 8 hours as extravehicular activity. Flying on the shuttle Atlantis STS-46, the crew deployed the ESA platform Eureka in 1992, on Endeavour mission STS-61 for the first servicing and repair of the Hubble Space Telescope. This was in 1993. On Columbia mission STS-75, the third flight of the US microgravity payload and the reflight of the tethered satellite. This was 1996. Finally, on Discovery mission STS-103 for the repair of the servicing of the Hubble Space Telescope. There was when he had the extravehicular activity that we mentioned before. His presentation is going to deal with the assembly of the International Space Station by astronauts and cosmonauts. You have the word.
Thank you very much, Andres, and muy buenas tardes to all of you. It's very difficult to follow the lively presentation by Pedro Duque, but I will give it a try. I'll talk about the assembly of the International Space Station and the means to perform this assembly. Now, obviously, to assemble such a large structure in space requires transportation from the Earth to space. And the Proton Russian rocket has been used, and the shuttle is being used now for all of the elements and until the end of the assembly. And of course, we need people to do the assembly on the spot in space. And there are astronauts and cosmonauts with, of course, a very strong support by a ground control team. The challenge of the space station assembly is how to go from here. This was the status at the end of 1998, when the first American element, the node on top, was assembled to the Zarya module in the bottom, which was the first element that was brought into space. 2, assembly complete in 2010. This is a depiction, artist depiction of the space station when the assembly will be complete. And of course, when the assembly will be complete, this will have included the installation of a major European element, as was mentioned before, the major Japanese element, and also the completion of the whole electrical power system represented by the solar arrays as you see here. Now, in order to perform these actions in space after transportation has been provided by Proton or Soyuz, we use mainly robotic means. And when I say robotic means, I mean human augmentation robotics. You see here, for instance, the space station robotic arm during the assembly of the airlock that was mentioned before. This happened about 5 years ago. And we use spacewalking means, or EVA. I use indifferently EVA for extravehicular activity or spacewalking. Astronauts in spacesuits doing work in space, in the weightless environment of space, such as connecting power lines or data lines or connecting fluid lines, or doing repair or maintenance as necessary. It's really a combination of the two that so far has allowed the assembly of the space station, and it will continue being the case for the next 4 years. Now, obviously, spacewalking means working in a bulky suit and with thick gloves, and you need quite a lot of training for that. And you need training in the spacesuits in a simulation of the weightless environment. And this is done primarily in large pools. This is the NBL Neutral Buoyancy Laboratory at the Johnson Space Center, Houston. There's a similar facility in Moscow called the Hydrolab, and there's even a facility for pre-EVA training available in Cologne to provide preparation of European astronauts before they go to Moscow or Houston for the final training. And we have the whole space station that is immersed in that large pool in Houston and used for EVA training. In particular, we have at this time Christopher Fuglesang, the ESA astronaut of Swedish nationality, that is in heavy training now before his mission at the end of the year, planned for middle of December of this year. Next step in the space station assembly, as was described before. Now, this is a nice picture because it depicts some of the elements of the space station assembly, which is, of course, the carrier, in this case, the space shuttle, docked to the International Space Station. And you have the robotic arm that is used, in this case, to do inspection and viewing. It's used also, as I mentioned before, to carry pieces of equipment from the payload bay of the shuttle to the mating element in the International Space Station, or to carry astronauts and bring them to the place of work. And here you have a spacewalking astronaut. So 3 elements for assembly: the carrier, the robotic arm, and spacewalking. Now, obviously, the spacewalking involves hard work. It's a lot of preparation. It's pretty hazardous also. You are less protected than if you are inside the space shuttle or the space station. But it's also an amazing personal experience, as you can imagine. The view is absolutely spectacular. And it's very hard to work in such an environment when you'll be tempted to look at the Earth or the stars all the time. This is a magnificent picture. I think that all of you here would like to be in the place of these astronauts here at the end of the space station robotic arm during a recent spacewalk. Now, Thomas Reiter, our man in space at this time, also had the opportunity to perform a so-called stage spacewalk in between visits by the Space Shuttle. That was on the 3rd of August this year, together with Jeff Williams. They performed several steps of maintenance of the station prior to the arrival of the shuttle a few weeks later. And you see here this little black rectangle. This is a camera, a so-called helmet camera. And I got to show you now a very short video clip, not of this particular spacewalk, but another spacewalk. So you will see what the astronaut sees during a spacewalk or what the helmet camera views. Here we go. You see your gloves, and you see the place of work here. And in a moment, you are going to see the astronaut translating along handrails. You see, this is a yellow handrail used to translate along the structure towards the payload bay of the shuttle, which you see in the background. Translation is very slow. You don't want to go too fast. You don't want to lose control. There's no friction, so you need to really be moving very slowly in order not to lose control. That's the common pace of translating along structure of the space station. And we use power tool like this motorized screwdriver in order to perform assembly of the space station, the various pieces of the space station. And here we are in the airlock, and he's saying goodbye. This is the current configuration of the space station following the recent shuttle mission a couple of weeks ago with the addition of the new solar array. And I show this picture to indicate that this is really a step towards exploration, which is the next program in the future. The space station program does not have a real end in itself, but it's a preparation program for the next steps. And whatever the steps, whatever the calendar, whoever the partners will be, robotics and spacewalking will be part of future exploration of space. And people, I insist people, will be major players carrying with them their capabilities, but also their values, their dreams, and their emotions. Now, I'm going to quickly go through the future solar system exploration program of ESA. I just have a couple of slides to describe this. Professor Messerschmitt already alluded to these future steps following the International Space Station program. This is called the Aurora program. It's a European Space Agency program that has an objective, future steps of exploration of the solar system using robotic means and human means. This is more or less the roadmap of these future exploration steps. On the left-hand side, you see where we are now. In the middle, you have, I would say, the 20s. And at the far right, you have approximately 2030, which is the time when we anticipate that there will be the first human missions to Mars. Important steps are ExoMars. This is a robotic mission, and you have a nice one-to-one model of ExoMars in the big hall, close to the cafeteria here. The launch is planned in 2011 or 2012, and it's going to be a really interesting robot on the surface of Mars that will have the capability of drilling under the surface of the planet. There will be human moon missions toward the end of the next decade, followed by Mars sample return at about the same time, and the first human missions to Mars I mentioned about 2030. Now, obviously, the Apollo program was possibly the greatest achievement of the 20th century, and these next step of exploration, the frame of the Aurora program, hopefully will contribute to a great achievement in the 21st century. And you see on this video the ExoMars, a robot just arrived on the surface of the red planet, is being activated and is going to perform this exploration. In particular, the search for water in a solid form, in the form of ice, in the subsoil of the red planet, and also of possible past life on Mars. This is a sample return, so towards the middle or the end of the next decade. The idea is to pick up samples of Martian soil and bring these samples back to the Earth. It's a very ambitious program, very difficult. Here you have the probe loaded with Mars soil sample returning to the Earth. I mentioned the human moon mission, and we will do this obviously together with our partners, probably the United States, Russia, and maybe others. And the idea will be to demonstrate the capability of humans to stay a long time on the surface of another celestial body than the Earth. also evaluate the capabilities to live from the land. We can extract a lot of materials from the moon and live from them, oxygen in particular. This is towards 2030, a big spacecraft en route to Mars with certainly an international crew. And at some point we are going to have the separation of the lander and the habitats module, you see this here, from the mother spaceship in order to perform the approach to the surface of Mars, land on it. This is a long trip. It takes about 7 to 8 months to go to Mars. It takes only a few days to go to the moon, but it's a much longer trip towards Mars, and it's a vastly more ambitious mission than to go to the moon. We'll go there. There's absolutely no doubt about that. The calendar has been set. Whether we'll be able to maintain it or not, I don't know, but we will go there, and I'm sure that the youngest people in this audience will be able to be Mars astronauts. The teenagers and less than teenagers in this room could become Mars astronauts. Thank you very much.
Claude, thank you very much for your interesting presentation. And I must say that although the first part of the EVAs and so are very impressive, but what is really impressive is what we pretend to do in the future. And in fact, I was going to ask you a question related with that. With the presentation, you have shown the International Space Station, Aurora, multilateral, etc., several things, but specifically about Aurora, this program, where it seems that is so ambitious. I'm sure that many people's main question is when are we going to be ready to do these space flights? And also, can you make a realistic guessing of that? Because many people ask questions when, and there are a lot of answers. You are an expert, maybe you can say something.
Well, that's a good question. It's a tough one to answer, I must say. As I mentioned, there is a roadmap. There's no doubt that the United States is determined to go to the moon by the end of the next decade. And I think they will be able to achieve that. Once again, the moon, we've been there, and the possibility for the US to go to the moon by the end of the next decade is certainly there, and I have all reasons to believe this will happen. For the next step, Mars in 2030, that's much more difficult to estimate. This is a number that has been given. I would give it a 50% chance that it could be achievable. And I would say that the obstacles on the road for human flight to Mars are not so much technological obstacles. I think they are more programmatic and to a certain degree political obstacles. But if at some point soon we make a clear statement that that's a clear goal that we want to achieve, we'll be able to achieve it as an international group of people, pretty much like was done in the 60s with the Apollo program. There was a very strong will by the US to go to the moon before the end of the decade of the 60s, and they made it. I think we could do the same for Mars. Thank you.
Thank you very much again. Well, I said, making a small mistake, that he was the last one, but it's not true. I'm just passing the chair again back to our chairman, because he's going to introduce somebody. Thank you.
Okay, thank you very much, Andres. It was very nice to have the European astronauts, but I think now we shall receive with great applause, I think it's in the back of the room, the first Chinese taikonaut astronaut, Mr. Yang Li Wei. Could you please come to the stage and make a presentation? Mr. Yang Li Wei, the floor is yours. Thank you.
Mr. Chairman, ladies and gentlemen, good afternoon. And now, today is the public day of this Congress for the exchange between the audience and myself. I would like to invite Mr. Ripoll to act as my interpret.
I will try my best. Thank you.
非常高兴再一次得到大会的邀请来参加国际宇航联大会。
It's my great pleasure to be invited to attend the IAC Congress 2006.
给我们航天员提供了这么好的一个平台来和大家进行交流。
And this really provides us a very good opportunity to exchange with astronauts and ladies and gentlemen.
大家知道，我在03年执行了中国的首次载人航天飞行任务。
As you know, in the year 2003, I participated in the mission of our China manned space program.
那么在2年以后，也就是在05年，我们的另外2名航天员费俊龙和聂海胜又成功的进行了太空飞行。
And you know, 2 years later, in the year 2005, we sent another 2 astronauts into space. That is Mr. Fei Junlong and Mr. Nie Haisheng.
那么这一次参加这次大会，让我有很多的感受。
This time to participate in this meeting, I have a lot of experience, a lot of special feeling.
那么借这个机会，我想主要谈谈我自己的一些感受。
I would like to take this opportunity to exchange my views with you.
因为这个大会已经进行了几百场的各个领域的技术的报告。
As you know, there are many rounds of technical meetings under this Congress.
也确实让我们感受到了太空的资源离我们的地球越来越近。
All of us has a strong feeling that the space is very close to us.
那么特别是今天让我看到了在场这么多年轻人，特别是看到了很多的青少年朋友。
This afternoon, I'm very impressed to see so many friends, especially so many young friends.
让我们感受到了我们人类航天事业的希望和人类的希望。
I have a deep impression about the future, about a space career, about the future, about the mankind.
那么这也使我想起当我飞行时候的那一刻。
And this really reminds me of that moment when I was in space.
当我刚刚走入太空的时候，当我感受到失重这种奇妙感受的时候。
When I was in space, when I entered into space, when I first felt the feeling of groundless.
当我从舷窗看到我们人类赖以生存了1万多年美丽家园的时候。
When I saw our beautiful homeland of the Earth.
让我感受到了人类的科技的发展和人类的伟大。
I had a strong feeling of the advancement, about development of our scientific technology.
同时也让我们感受到了载人航天这个事业确实是我们人类共同的一个事业。
I'm very impressed with that. I had a feeling that the manned space project is actually a common task of the whole mankind.
因此，在我飞行的时候，我展示了中国的国旗和联合国旗帜。
So when I was in orbit, I showed the United Nations flag as well as our national flag.
来表达中国人来发展航天的一种美好愿望。
To express the goodwill of our country to make peaceful use of the outer space.
就是更好的和平利用空间，为人类来造福。
For the benefit of the whole mankind.
那么我想我们这次参加大会，有来自不同国家、不同文化背景、不同肤色的人们。
And I know that people for this Congress are coming from different cultures, different walks of life.
我们就是为了一个共同的目标。
And we are here for the common mission.
就是为了如何来利用空间的资源，来为人类造福。
That is to make use of the resources in space.
那么随着人类社会的发展，科技的发展，人类是始终要走出我们地球的。
With the development of mankind, finally man will go out of the Earth.
正像我们一位科学家说的那样，地球是人类的摇篮，但是我们不可能永远停留在摇篮里边。
I remember that one scientist decided that the Earth is our riddle, but we can't rely on it always.
因此，通过我的执行任务以及我和我的同行们的交流，让我深深地感受到我们这种合作的重要。
So I had a deep impression through exchange views with our colleagues from all over the world. I deeply think that the cooperation all over the world is very important.
因此，当我在飞行的时候，也向我的同行在空间进行了问好。
So when I was in orbit, in flight, I said hello to my colleagues.
那么也通过飞行让我深深感受到了航天技术对给人类带来的这种方便和造福。
And I also had the feeling that with the development of our space technology, it will benefit the mankind.
比如这一次在大会上，我们看到了很多利用太空的资源，比如说我们的灾害的预测以及我们资源的保护。
For example, it can be used for disaster relief and also for the protection of our resources on the Earth.
确实需要我们大家共同来为我们的事业来努力工作。
So we have to join hands together to work together for the common task.
正像我从我的家里走出来站到门前的时候，我面对的是一个社会。
As I go out of my home, I will be faced with the whole society.
那么当我在太空当中去看宇宙的时候，是站在我们地球的门前去看整个的空间。
When I was in orbit to see our beautiful Earth, it's just like I went out of my home to see the society.
因此呢，在这里我非常愿意和我的同行们一起，在互助互利的条件下，能够合作，能够努力的工作。
So I would very much I like it very much to exchange with my colleagues, to cooperate with my colleagues under the mutual benefit principles.
那么也借这个机会，简单的给大家介绍一下中国的载人航天工程。
And I would also like to take this opportunity to introduce our manned space program to you.
那么中国的载人航天工程是由7个大的系统组成的。
You know, China Manned Space Engineering Program is composed of 7 subsystems.
那么第一个大的系统就是航天员系统。
The first system is astronaut system.
这也是我现在工作的一个系统。
And this system is what I am working.
那么第二个大的系统就是空间的应用系统。
The second is scientific application system.
那么第三个大的系统就是我们的飞船系统。
And third system is our spacecraft system.
第4个大的系统是我们的火箭系统。
And fourth is the rocket system.
第5个大的系统就是我们的发射场系统。
And fifth is our launching system.
第6个系统是我们的测控通讯系统。
And then the sixth is a TT&C system.
第7个大的系统就是我们的着陆场系统。
And seventh is our landing system.
那么在这里给大家介绍一下我们的航天员系统。
And then I would like to add a few words with the astronaut system.
那么中国的航天员系统，我们现在叫中国航天员中心。
We call the astronaut system China Astronaut Training Center.
它主要是为我们国家培养能够执行任务的合格的航天员。
This center is responsible for training capable astronauts of China.
同时，在研究太空这种环境对人体带来的一些影响。
And at the same time, it will make research in the space effect on humankind.
以及和人有关的一些产品。
And also some products, some materials that is related with human being.
比如我们的航天食品。
For example, the food for the astronaut.
我们航天员执行任务时候穿的航天服。
The astronaut suit.
以及我们飞船的环境控制和生命保障系统。
And also the life support system and the environment control system.
那么我现在在这个中心里就负责航天员的选拔和训练工作。
And I'm now in this center for responsible for the selection and also the training of astronauts.
因此呢，今天我看到我们这么多的年轻人。
So I'm very glad to see so many young people here.
我希望能有更多的人能够加入到这个队伍当中来。
I hope that in the future more young people can join in our team.
和我非常愿意和你们一起进行工作。
I would very happy to work with you.
因此呢，在这里我也衷心的希望大家能够有机会到中国、到北京、到我们的航天中心去看一看。
So I hope in the future you could visit China, visit Beijing, to see our astronaut training center.
再次感谢大会给我的这个交流机会。
Thank the organizing committee again for giving me the chance.
再次感谢大家对我们中国航天的这种关注和支持。
Thank you again for your attention to China Manned Space Engineering Program.
谢谢大家。
Thank you.
Thank you, Mr. Young. It was a very interesting presentation. Just one question, like we did with the European astronauts. When do you expect to have a Chinese man in the moon?
你觉得对那个中国登月有什么想法？
我想，正像我刚才说的，随着人类社会这个技术的发展，我们会越来越走出我们的家园。
Just as I said, as I mentioned, with the development of the space technology, a human being will go further away from our homeland.
那么这种深空的探测也是我们所要进行的一个方向。
And it's one of our tasks to make deep space exploration.
当然，作为月球，我们的人类已经有人登上了它的上面。
As everybody knows, a human being has touched on the moon.
但是利用这种太空的资源是我们每一个人的责任。
But it's everybody's responsibility to make use of space resources.
因此，作为我们国家，我们也在这方面进行一些预研的工作。
For our country, we have been doing some preliminary research work.
所以我想中国人有一天也会登上月球的。
So I hope and I believe that in the day of the future, Chinese people will land on the moon.
因为大家知道，中国有一个非常美丽的传说。
You know, in China there is a very beautiful tale.
嫦娥奔月。
A very beautiful girl named 嫦娥 pursuing the moon.
那么今天正是中国的中秋佳节。
You know, this very day is the Mid-Autumn Festival of China.
这个节日就是讲月亮的故事。
And this festival is about the story of the moon.
因此，在这里，我想和大家一起共度中国的这个美好节日。
So I'm very happy to celebrate this traditional Chinese festival with every one of you.
谢谢。
Thank you.
Thank you very much. I will pass the floor to Mr. Ripoll to make a final words on the overall afternoon session with the astronauts, and I will kindly ask Mr. Young to sit in this seat, and I'll stand. Please take my seat.
So, well, it seems that I have to say a few words about to summarize the plenary event. Well, first I believe we have accomplished the objectives of the plenary event. You remember at the beginning that we said that we were going to talk about the present, and this is the International Space Station, what we are doing and so. And I think we said something very interesting. Second, the strategic vision beyond the International Space Station, and this is the future. And third, exploration of Moon and Mars, wishes and facts, for example, Aurora of the European Space Agency. We initiated this plenary event saying that the wishes of women and men to travel to space were long-awaited dreams. It is no longer a dream. The present generations are taking very seriously the space tourism. We have heard our friend Thomas Reiter saying that just a few days ago we had a tourist in the space station. It is also to find some authors for whom tourism will be in the future the first economic profiting activity in space. I can give you some ones if you like. I believe we might conclude this plenary event with the famous statement of Albert Einstein. One of the most sublime things that man can experiment is the attraction for the mysterious. All the art and science are born there, hoping that this attraction, this curiosity, will inspire our future generation. We thank you very much for your attention.
Thank you very much, Andres. Very nice words. But now that's the real moment. Let's have the audience asking questions, and mainly the audience from the young boys from Spain. Podéis hacer todas las preguntas que queráis. Andrés y yo haremos de translators para las preguntas que queráis hacer en inglés. So I ask the audience, Spanish or non-Spanish, to make questions now, because later on it's going to be late. We are going to have dinner and go to bed. So that's the moment to make questions. ¿Quién quiere hacer alguna pregunta? A ver. Ninguno de vosotros quiere hacer ninguna pregunta, pero qué tímidos son los valencianos. A ver. Yes? The micro? No.
Yes, I was just wondering, when will the first Chinese man visit the ISS?
Could you repeat the question, please?
I would like to know when the first Chinese person will visit the ISS, the International Space Station.
Oh, when the first Chinese man will go to the International Space Station?
刚才我也讲了，这个作为一个航天员，我愿意和世界上各个国家的同行们一起进行工作。
Just as I said a few minutes ago, I would very happy to work with our colleagues.
当然，这个作为我们这种互相之间的这种了解，我想通过我们的各种活动、各种的大会，会增进我们之间的了解。
I understand that all the Congress meetings and exchange of views will enhance our mutual understanding.
那么在这个基础上，我想在我们这个载人航天的这种合作的这种大的趋势下，我想我们会在合适的时间，会和我们的同行们一起进行在太空当中飞行的。
I think we will join hands with our colleagues from Europe, from the States and Russia in the space.
我们也在努力的进行这方面的工作。
And we are making our effort in this regard.
谢谢。
Thank you.
More questions? Preguntas? There's a young boy there. First.
Gabriel, ¿hay mucha basura alrededor de la estación espacial?
Perdona, repítelo.
¿Hay mucha basura alrededor de la estación espacial?
¿A quién se lo quieres preguntar? ¿A Pedro Duque? ¿A quién? Okay, he's asking to any one of you to take the floor if there is many garbage around the space station.
I can take that. There is a lot of material coming from asteroids, from meteorites, and of course also a few pieces.
Let me translate.
And also a few pieces from satellites.
Está diciendo que hay mucha materia alrededor de una estación espacial, materia que es celeste, meteoritos, pero también hay objetos producidos por la estación espacial.
But we have to prevent this in the future. It is certainly some hazard for astronauts in space but the risk of having problems in launch and landing are much higher.
Sí, entonces, por lo tanto, hay que tener mucho cuidado con todos estos elementos, no solamente para la vida de los astronautas, sino para tenerlo en cuenta en los próximos lanzamientos para evitar este tipo, tener órbitas que sean las más limpias posibles. No. Botón.
En estos momentos no tiene una imperiosa necesidad de llegar a Marte ni a la Luna, pero sí de resolver el problema energético. ¿No sería más racional dedicar más recursos a ese problema, incluso dedicar más recursos a nuevos sistemas de propulsión?
¿A nuevos sistemas de?
De propulsión. Y no volver a la Luna o a Marte hasta que no esté resuelto el problema energético o el problema de propulsión.
Entonces no volveríamos nunca. Okay, the question is, in view of the problems we have on Earth right now, apparently it's not of major use to have men going either to the Moon or Mars, and then his question is whether the money spent in going to the Moon or Mars could be wisely spent, for instance, in making better propulsion systems for our own launchers. Maybe Pedro, I noticed he's willing to answer this one. You can do it in Spanish and English. But...
Vale. Bueno, claro, la pregunta es un poquito parecida a la de la gallina y el huevo. Si no tiene uno cohetes no puede ir al espacio y si no se aplica al interés de ir al espacio, tampoco habrá nunca dinero para hacer cohetes. Entonces, pues no es tan fácil de decirlo. Los siguientes métodos de propulsión que se inventen tendrán que requerir muchos y muchísimos años de desarrollo y, por lo tanto, pues creo que es sabio no parar todos los vuelos espaciales hasta que no tengamos sistemas completamente distintos, porque si no dejará de haber interés por financiar estos propios desarrollos.
Gracias.
¿Me dejas? Bueno, yo añadiría que el hecho de intentar explorar la Luna o Marte o cualquier otra exploración de estas así tan futuristas realmente exigen el desarrollar, y allí es donde porque los recursos que se ponen allí dentro no son solamente para ir a Marte unas personas sin hacer nada de desarrollo tecnológico. El desarrollo tecnológico permitirá que haya unos lanzadores mucho más modernos. Ahora andamos con carabelas para el espacio, eso lo sabe todo el mundo. En el futuro será de alguna otra forma. Yo añadiría esto, si Pedro está de acuerdo, me parece que sí, ¿no?
Gracias. Que apagar el micrófono, por favor. Y a ver esa niña.
¿Qué pasaría si la Tierra se saliera de su órbita?
No es fácil, pero... Okay, the question by this young lady, maybe anyone likes to take the stage, is what will happen if Earth will leave its orbit? Who cares to make an answer?
I can't answer in Spanish. Earth should not leave its orbit because the laws of how bodies move in the solar system are very well established, and this could not happen except in a dream. If it was happening, of course, it could possibly make traveling to the solar system cheaper because the Earth...
Give me a second. So, lo que está diciendo el señor Nicollier es que la Tierra no puede abandonar su órbita porque la Tierra naturalmente está sometida a las leyes de la mecánica celeste que hacen prácticamente imposible que esto ocurra. Ahora, si por una circunstancia excepcional o por un acto divino pues ocurriera,
yeah, if it were to happen because of a change of the laws of physics or in a dream, then it could make traveling to the solar system cheaper because we could go to Mars because Earth would bring us there, for instance.
Dice que entonces lo que haríamos es viajar por el sistema solar de una forma más económica porque la Tierra nos llevaría a una órbita distinta a la que tenemos, precisamente porque la abandonan.
I think it's a wonderful dream idea. Thank you for the question.
Dice que es un sueño maravilloso, pero Muchas gracias por la pregunta, pero no sería posible.
Good afternoon. I would like to know when ESA will start to select the new astronaut corps.
You have a candidate there.
So the next astronaut selection will start as it has been scheduled already on the different papers that we have, which is after the successful launch of Columbus, launch and docking of Columbus, and when we have clearly identified what are the number of flights after the launch of Columbus in order to fulfill Columbus. So we are looking at around next year to start the selection.
More questions? There is a question in the back.
Well, my question is general, and I'm not a child, and I am a woman of over 50, and my question is real that our son, our new generation, that they are perhaps 20 or 30, won't be able, well, they won't need to go to America as Pedro Duque went to do or to research or to find a job. And do you think really that in Europe there will be enough money, or they will invest enough money that our young generation can work here in Europe and not go into America as before? Well, my question is for everybody, but especially is for Pedro Duque, that he is not here.
Well,
but I can wait. Or if any of you wants to ask,
he's coming back.
He's coming back. Well, I can speak Spanish as well, but as I imagine in general here, most of the people here speak English, as I did my question in English. If you want, I can translate it into Spanish. If anybody wants me to translate it into Spanish, I will do it.
I think I can try to give you my perspective on this, and of course I'm speaking as an astronaut who is concerned about the same question that you have just addressed. But I would like to recall that the European Commission has in Lisbon in its last meeting clearly declared that education will be the prime goal for Europe, and that Europe should become what was called a knowledge-based society. I think we have understood that knowledge is key to our future. Now, I do not see it only negative that our people are leaving and going to the United States to learn and to study there. I did it myself, because many of them will come back and they will learn.
Yeah, but not everybody could go.
In a world that is growing together and coming together. So what I would hope to see is that indeed our politicians, and this is what we try to do when we prepare for space, to communicate to them as well, that they focus on the importance of science for our societies in Europe in general. It is not only true in Germany, the same is true in France, in Spain, in Italy, and that this eventually will lead to a prosperous future for each and every one of us. But I still would hope that my children, and I have 4 of them, will do the same as I did. Look abroad. It does not need to be the United States. It can be China, as we have heard. It can be Russia. But look somewhere else, because we can learn a lot from the people in other places in the world.
Yeah, I agree with you, because it's
was
not
one question, excuse me. Many people is asking questions. You have one question. Let's give opportunity to another person. There's one here, one there.
I looked very carefully at the picture of the astronaut corps, and I could see that there were 16 men. What is the cause that there is no woman in this corps, and what is ESA going to do about it?
You did the last one.
So we make a deal with Gerhard. I will do the very difficult question. This is a difficult one. So we do open the previous selection to both men and women, but for any reason that I cannot explain, we had less women, and the few that came to EAC and to ESA left quicker than the men for other reason, for personal reason or for private reason, but they left. We had just one woman that flew in space twice, Claude, she's French, and she left the Corps to become a French minister, which is a very nice example of success as well, because you fly in space and after you talk to the government and you try to get more lobbying on the space program. And now she is back to ESA as a special advisor of the general director. We had another woman astronaut, but she left before she could fly in space. But I can guarantee you that on the next selection that we are preparing right now, we will have women coming to the selection. We don't close that to women. We want to have women, but we just need also to make the criteria of selection the same for men and women, and this is difficult.
We have a question, Mario.
May I add? Let me add something to this question. Since I participated in selections, I must say that we did some studies and comparisons, and we find out that at this time, at least, I'm talking about 12 years ago, only 12% of women were asking to be astronauts. When we sent the proposals, and we asked the Americans what happened with them, and more or less they had the same thing, and also the Russians. So it seems that is something. Are the women who had to change this? We cannot.
Mario.
Yes, when I travel, but I only travel to Valencia, for example, I see other people, I learn things, and I come home differently. I would like to know if you, being in space, that have changed your mind.
To whom is the question? Que si cuando viaja se cambia, que si estoy viendo el espacio cambió.
我想我和我们所有的同行一样，太空的飞行并没有改变我们。
I think just as anybody else, it didn't change us when we come back to the Earth.
当然，这个航天飞行是一个很特殊的职业。
But as you know, to fly in orbit in space is a very special job.
当你在这种特殊的环境下，需要你有很多的和我们一般人工作环境不一样的一些素质。
Under these special conditions, it's a very challenging thing. It needs that it requires that you should be a special figure.
那么通过我们的训练和我们的努力工作，这一切对于我们来讲都不是问题。
Through training and hard work, we think that this really we can overcome them.
因此，我现在还在进行训练，还在迎接着我们今后的任务。
So I'm still in training, and I will accept new job, new mission.
这也是我想和我们的同行一样共同的一个愿望。
And I think this is really a common hope of all the astronauts, all the colleagues.
当然，心理的问题是我们作为一个航天员特殊职业的一个很关键的一个问题。
And I think that psychology is really a very important factor.
这也是我们选拔航天员的一个课题。
And this is one of the main factor for us to select new volunteers.
好，谢谢。
Thank you.
All right. Thank you. Last question. It's already, excuse me just a second, it's already 7 o'clock. I'm sorry, we shall close the event. I know that there are thousands of questions. Probably the astronauts will be kind enough later on in a more private arrangement to answer more questions, but now, because we have a banquet and we shall close the Congress, we have only room for one question. I think it was this lady there. Okay.
I would like to ask the astronauts how it feels to sleep in space, and do they need to strap themselves, or do they just float, and how they feel when they wake up?
Who is making the answer?
Living in space is a wonderful feeling. After maybe a few hours or sometimes a few days when you need to adapt and you may not feel physically 100%, but after these few hours or few days, it's a wonderful feeling to be floating in the cabin. And I think all the ones who are here and all the astronauts who have flown in space have had very positive impressions about that kind of freedom that you have when you float in the cabin. Imagine in this room, if there was absence of gravity, we could move along the whole volume and put your feet on the ceiling or on the side wall and push yourself from the side wall and cross the whole room. It's a absolutely great feeling. The other part of the question? Yeah, sleeping. You said sleeping. Although there is relatively little physical work during the day on orbit, except if you go spacewalking, then you become physically tired. But if you stay inside the cabin, you are not physically tired, but it's mentally rather tiring. So that the night or the sleep is a pretty good quality. The whole flight plan is divided in slices of 24 hours. In a slice of 24 hours, you have a 7 to 8 hour sleep period, which is normal. And you sleep quite well. And I must say, when you wake up, you are very happy because you anticipate another great day on orbit.
Very good. Thank you very much. Thank you. So, as I said, I'd like to wrap up this meeting. Questions can be placed personally. Of course, don't press too much the poor astronauts. They are also human beings and they need to rest. I'd like to thank ESA and China both for lending us their astronauts for these questions. I'd like to thank the people of Valencia, the school children from Valencia, to be able to come today and to make such interesting questions, and of course all the delegates of this Congress. That's the last event, a formal event of the Congress. I wish a good trip back to all of you, and thank you very much for everything, and Visca Valencia.